The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, everybody, and welcome to today's webinar, Most Economical In-Building Coverage Solutions for CRE. My name is Ian Gillett from IGR, and I'll be acting as host and moderator today. We do have a guest speaker today, which I'll introduce in a few seconds, but before we get started, I want to go through a few logistics, and then I'll run through the agenda, and then we'll get started with the main content. So firstly, we are recording today's webinar. The webinar will be available, or the recording will be available in a few days. We have to convert the file and we put it on the website. So you'll receive a notification with the details on how to download that. And then secondly, we will be taking questions today as well. If you look on the GoToWebinar control panel, you'll see a questions tab about halfway down. If you just want to type in your questions there, we'll either address them during the main session, or we'll have time at the end to address all the questions. So feel free to type away. And then the final thing is we will be sending out the slides today for today's webinar. So no need to try and write everything down or screenshot everything or draw pictures. You'll get a notification afterward of the how to download the slides. Okay, so with that, I'll run through the agenda, then I'm going to introduce Frankie, and then we'll get into the content. So firstly, I'm going to kick things off and talk about the indoor small cell opportunity. I'm going to talk about basically how much opportunity there is in this space versus how many solutions are actually installed. We'll talk about the commercial buildings in the US in terms of the number of them and then the size of the buildings, and you'll obviously, this is your market, this is the CRE market, but it'll give you an idea of the size of the problem. And then Frankie is going to jump in from Shawcall and talk about the company. He's going to talk about passive DAS, so distributed antenna systems, how they're deployed in a building, what they provide for in-building cellular coverage. And then he's got several case studies to run through exactly, what they've done, where they've been deployed, to give you some ideas and show you the breadth of the variance of the solution, if you like. And then final section is we'll run through actually the design and install process of how you actually go about mapping the solution for a building and then installing the solution itself. And as I said, we'll have time for questions at the end. So with that, I'm going to kick things off here. Firstly, there's a picture of me on the left, and there's this nice color photo outdoor of Frankie from Shawcall. He will be speaking later on, and obviously he's VP of Sales. He's based down in Atlanta. I'm in Austin, Texas. So we've both got good weather, and things are pretty good today. So with that, that's who you know. That's now who you know who's talking, what we look like. So with that, let's kick off. I'm going to kick off here. So when you look at the size of the market here, the blue line here is basically showing how many small cells we need to put in commercial buildings in the US in order to provide coverage to an indoor building. Obviously, more people are using smartphones and tablets in everyday life, and they're using them more and more at the office, in the workplace. It's not just for work, obviously that is part of it. It's also to keep tabs on personal life and things like this. So for example, we did some work a couple of years ago talking to employees in commercial office space, and we asked them, well, what do you want to do at your desk with a smartphone or a tablet? And one of the most popular things, for example, is to look at a nanny cam or a pet cam to keep an eye on the child or the pet during the workday, and obviously got a camera set up in the home. Now, the reason they don't use just the regular old office Wi-Fi is a lot of times the firewall in an office will block streaming video from outside the office. So getting that nanny cam onto your desktop, for example, can be very problematic. So hence, just use the iPhone, just use the Android, the tablet, whatever, have it sitting on your desk and use LTE. Another popular one was actually doing banking, personal transactions. This one was more of a concern that obviously with a corporate network, a lot of companies monitor traffic or blocks access to certain sites, as we said. And so a lot of people don't want to actually use Wi-Fi or aren't able to use Wi-Fi to get into their bank account, for example, to pay bills or something like this. So again, doing that on a lunch break or whatever, using their personal mobile device was pretty popular. And finally, it was just a lot of privacy. They just didn't want the company knowing who was calling them, what they were doing. It was just the ability to make personal private calls or texts, Facebook, whatever it was. So the blue line basically says, hey, if we provide coverage in all the commercial spaces in the United States that have poor coverage today, and not all do, but the majority do, then that's the blue line. And you can see it increases steadily over the next 5-6 years. The reason it increases, of course, is because we're building more buildings. I live in Austin, as I said, and if you look at downtown Austin today, it's very different from where it was 5 years ago in terms of the number of high-rise buildings. Frankie's in the Atlanta area, and that's absolutely the same. I've been there recently, and it's booming as well, as are a lot of other places. So more office buildings, more commercial spaces, more need for coverage. Simple as that. The red line is how many of those buildings have actually got solutions in place today. And I showed this as a node forecast. So this is actually cells that are actually sitting inside the building. And you can see in 2017, we've actually addressed about 7% of the need, which obviously is good news for solution providers. There's a lot of room there to grow, clearly. By 2022, we're up to nearly 10% of the market. So the market's growing overall, the penetration is growing. So clearly more systems are going in, solutions are being deployed. And the actual growth is actually between 17 and 22 is about, it's just under 16% compounded annual growth rate per year. So it's a pretty healthy market. And I think Frankie will attest to, it's a pretty good place to be right now. But certainly in terms of, is the market saturated? No. Do we have opportunities? Absolutely. And also from a CRE point of view, look at this from a building owner or a building manager, is the likelihood that the building next to you has got an in-building solution? Well, it's about a 7% chance right now, depending on the age of the building and size and things like this. So chances are that the building next to you, your competition, does not have this type of solution. Therefore, if you were to deploy something like this, then and we're able to provide coverage in building, then obviously that's going to realize a competitive differentiator for you. So in terms of this is a question that we get a lot is, well, how are the commercial buildings made up in the US? Well, what are they? And this actually is from CBEX. It actually comes from the survey, what do you call it? The survey, population survey they do every few years. This is actually from 2016. And you can see the colors on there on the side. But number one use of commercial building space in the United States is office space. It's actually about 18.2% of the buildings out there, and it's this green area down here at the 4 o'clock to 6 o'clock position there. Warehouse and storage is second at 14.3%. It's actually this, it's at the 9 o'clock to 11 o'clock position here. And then services industries. Obviously it could, and it's not food service, by the way, or food sales, but it could be, it could be some sort of health solution or things like this. Then that would be it's 11.1%. It's down at the 8 o'clock to 9 o'clock position down here. Now, the reason I picked those three out is they have very different needs in terms of in-building coverage and capacity to use smartphones and tablets. So if you think about an office space, you're going to have a lot of people in there. Let's say it's more of a white collar type solution. You're going to have a lot of people in there with probably high-end smartphones using a lot of data, doing a lot of different things. In a warehouse and storage, you're going to have far fewer people, a lot more stuff. So that's when Internet of Things comes in, those types of solutions. But relatively few people in a warehouse, obviously a very big space. And certainly the way those two types of buildings are constructed is very, very different. And obviously that impacts the type of cellular solution we put in building and how it's architected, how it's designed, etc. And the same for the services industry there as well. So a lot of variation there. And then last slide for me, then I'll hand off to Frankie. And this is the size of commercial buildings in the US. About 12% or over 25,000 square feet. So the majority, of course, are actually in this blue area here. As you can see, the blue is less than 5,000 square feet. The red is 5 to 10,000. And then the green is 10 to 25,000. So we have a lot of smaller buildings in the commercial space in the US. We have actually relatively few over 500,000 square feet, but hey, they're very big buildings. So don't discount that opportunity. It's obviously they're large buildings, and there are thousands of them. There are, I think, there's about 7 or 8 million commercial buildings in the United States. So clearly a large opportunity, a big variation in how buildings are used, which impacts the type of solution you put in, big variation in the size of building, which impacts the type of solution you put in. And then, of course, that now leads me to hand over to Frankie here, who will be able to explain more about what SureCall does and how the solution fits into these types of opportunities. So, Frankie, over to you.
Thanks, Ian, and thanks everybody for joining us here today. Just to give you a little bit of information about SureCall, we are the performance leader in the passive DAS technology, which is also called, can be called a cell phone signal booster, or BDA, a bidirectional amplifier. It's all that we do. We're very focused on bringing signals from the outside inside to the building or to the home, wherever it may be, where we want to stay connected. Next slide, Ian. A little bit about SureCall. So you see here, this is Hong Tao Zhan. He's our founder and CEO. He has a engineering background. He's first generation Chinese American and truly a great visionary and entrepreneur. He holds several patents in our business here in our industry, and is a big reason why we're part of the Inc. 5000 list of fastest growing companies the last 3 years running. But SureCall in general has been around for about 17 years. And our main focus has been on the commercial enterprise type of market space. And again, very innovative. That's a lot of our focus. We were the first ones to create a 5-band signal booster that could do all carrier signals simultaneously inside of a building. We're based in Fremont, California. If you're familiar with Tesla, we share a cul-de-sac with them. So that's always interesting when we're up there at the home office. And we have a US-based technical and sales support to support the process all along the way. So how exactly do passive systems work? So they actually use a series of antennas, cables, and bidirectional amplifiers. And there's an antenna that would go on the roof that's actually capturing the signal from the nearby macro site or cell tower, right? Over the air, as some call it. And it's captured and it's rebroadcast through the coax cable, which is typically an LMR400, to the BDA, to the bidirectional amplifier. From there, it's sent out back through the coax cables to the antennas that are networked throughout the building, and then the signal is rebroadcast inside the building from those antennas to your device, and it's also boosted signal back to the cell tower. So you're getting both the downlink and the uplink gain. And the reason that we have this graphic here to the left showing the signal strength readings is that a passive system is based on several variables, but one of the most important variables is that strength of signal coming inside. We're very reliant on that strength of signal. Typically, the stronger the signal outside, the better a passive system is going to perform inside the building. If you have weak to no signal outside, that wouldn't necessarily be a great solution, or passive DAS wouldn't necessarily be a great option for that particular building. So applications for passive DAS. So obviously commercial buildings. In the graphic that Ian just showed, with the square footages up to a couple of hundred, few hundred thousand square feet and below, over 80 to 90% of the buildings in the country are really a good solution for passive DAS. And that comes in all types and all various shapes and sizes, whether it be the office spaces or warehouses, data centers.
It looks like we lost Frankie's phone call. Looks like it dropped. So I'll give him a few minutes to dial back in. Aaron, if you could just text him, just let him know, just in case he hasn't realized he may still be speaking. I'll continue here. So obviously what he's saying here, showing here is that applications for passive DAS obviously are pretty wide and varied, as I showed that slide, between the commercial buildings, government, higher education, etc. But again, just looking at the photos, the images here, you realize that there's a big variation in the types of buildings, both in how they're constructed and also in the size, number of floors, etc. From a radio perspective, if you look at the bottom image with the that glass two-story building there, looks like a nice office space, you would think actually that the cell tower on the outside of that would be able to penetrate the building pretty easily. In fact, a lot of new buildings and homes actually have low E glass for to keep the heat in or out, depending on climate. Low E glass is really good at blocking RF signals. Actually, as you get higher in the frequency bands, the radio signal will actually bounce off those windows, especially if they're wet. Water, radio signals don't like water. And again, if you look up the building, if you look at something like the old the clock tower building there, looks like a old university, you would think that that would be a horrible RF environment. Actually, sometimes brick, depending on the age of it, can be pretty good. Again, lots of windows, but you'll notice it's got a copper roof on it. Metal roofs are really bad for penetrating RF. So again, the variation here that you get with those buildings is very important. It doesn't look like we got Frankie back yet, so I'll just continue filling in here. So the benefits of the DAS here, the passive DAS, and you can see there's a picture. Oops, what's happening? There we go. There's a picture there on the right-hand side of a building showing the antenna collecting the signal from outside. The amplifier is number 2, and then going through the connections throughout the building to those indoor antennas. Firstly, passive DAS has been approved by the carriers, so the carriers do recognize that these solutions are out there. That makes it for a faster deployment here. You don't have to get an operator involved in the building, so you don't have to call, if you've got a corporate agreement with one of the carriers, you don't actually have to call them to pull them in to get the install done. It is carrier agnostic in that, as Frankie mentioned, all major carriers are supported. So rather than focus and just say it's only going to rebroadcast an AT&T signal, for example, or only a Sprint, it will actually take from all the major carriers. So it doesn't, the system really doesn't care what is being broadcast, but rather which frequency it's on. You can control the frequencies that are boosted inside the building. Cost effective, we'll talk about in a second here. There's actually a little asterisk there, and if you look below, Frankie and I are going to have more of a discussion about that later on. But typically around 75 cents per square foot installed on average. It does vary again depending on the type of building, the size of building, the construction of the building. And obviously you've got some wiring to put in there. So, there is labor in getting that wiring through. The harder that is to do, the higher the cost. Simple as that. To give you an idea, if you were to put a traditional active DAS system, those systems vary, and that's one with its own radio source. It's got its own cell inside the building. And those typically range from a couple of bucks a square foot up to $4, $4.50 on the more expensive side. And then obviously a scalable solution. You can deal with large buildings, you can deal with small buildings. You can deal with a building that's maybe an office space at the front and a warehouse at the back.
Hey, this is Frankie. I'm back.
Hey, Frankie.
I apologize for that. I was just going to town and thinking the slides were frozen, and so I just kept on going.
I asked Darren to contact you. I don't know if he did so. I kept on speaking, so I finished off your last slide. On this one, I talked about it being carrier approved. I talked about being carrier agnostic, and I was talking about the cost effectiveness, if you like. I talked about the 75 cents per square foot. And actually, if you want to take over, there is a question here that we can probably address at this time. So when you put a system in, is it a one-time payment? Are there ongoing payments? How do you, who pays what, and how do you fund it? And I'll hand over to you.
Sure. So before I answer that question, let this be a lesson to you that VoIP, there is no one perfect solution. Any technology is susceptible to dropping calls. But to answer that question, typically it's one payment, right? It's the labor, it's the hardware all at once. Most installers would want somewhere around 25 to 50% upfront, and then the additional payment once the system is commissioned. Now, if you choose to have the remote monitoring feature enabled, that's something a little bit different. Some installers might charge a monthly fee or a yearly fee to monitor the system through our Century remote monitoring software. And that's probably a few $100s a year or so.
Okay, so if you want to carry on, then I'll let you continue.
Sure. And so you made it through this page, is that right, Ian?
Yeah, the only piece I didn't was just talking about scalable. I didn't get to the remote management piece, so that'd be a good place to finish up there. Okay.
Yeah, so kind of just touched on that. A couple of our products have that functionality. One of them has it built in to where your IT person or the installer has the capability to dial into the system and check all of the downlink power, the gain, and show exactly how much the system is boosting and increasing the signal. So that's a great feature to have, to know when you say you're going to boost cellular signal, it really helps quantify it to you, the building owner, and to the installer as well. So we can move on to the next slide here. So as we talk about a couple of our in-building solutions, the first one is our Fusion 5X 2.0. This is the one that is great for mid-sized buildings. It has automatic gain adjustments, and it comes in a couple different versions with the different antennas, and it has antennas that are able to rebroadcast the signal in a variety of different ways, just like our other solutions do, and I'll get into the antennas in a moment. But it has twice the performance than some of the other competitors in the market space on the downlink power side. So when the signal is really strong outside, so maybe it's your building, just you can't penetrate through the building, but when the signal is really strong outside, this has a higher ceiling, so to speak, of how much more signal it can push out through your building, covering more area. So a great solution for your warehouses or small office spaces. And again, being scalable, you can put multiple in a building as well. So as we move on to the next slide, and we talk about our workhorse, our Force 5 2.0, this is the one that's for your larger commercial buildings, your ones where you're gonna have more capacity. This one has the ceramic filters to help with that capacity, and it's highly linear, meaning it doesn't drop off on any of the sub bands, so you can get as much data throughput and many simultaneous voice users on it as the tower would allow, right? Because that's typically where the capacity constraint is when we talk about capacity. Rarely ever is it through the booster itself. It's mostly at the tower at the macro level. But this one's also voice over LTE certified, so you won't have any issues there. and it comes with that built-in monitoring feature that I was mentioning. It's called the Sentry. You have the Ethernet cables there that you can connect right to a modem on site and dial it right in to do everything that's needed. And both these boosters have our SureIQ technology, which means whenever there is a strong signal outside, it will not overpower the unit. Anybody in this call with any experience with boosters over the last few years, they might have experienced that overpowering issue, which was a requirement by the FCC, which has since been levied. So the SureIQ technologies ensure that you're going to have that constant uptime when the booster is powered on and tuned. So I wanted to spend just a second to show you the internal antennas, because this is from the installer does a great job. This is all you're really going to see inside your office or inside your building, these antennas. You have two omni antennas, meaning they're going to send signal out in a 360-degree direction. That's the dome and the ultra-thin antenna. The dome antenna is 7 inches, and it's 4 inches hanging down from a drop ceiling. The ultra-thin antenna is a little bit wider base at 12 inches, but it's much more lower profile. And it's a bit of a better performer. It can push out more signal. And then we have the panel antenna, which is a directional antenna. So that would go on a wall facing where you want to see the improved coverage. It could even go above the ceiling if you have a high enough ceiling, as the signal from the antenna goes out about a 60-degree beam width. But those are the antennas. That's the only thing you should see once the installation is complete. All the cables should be behind the walls or in chases, and the antenna and the amplifiers themselves should be maybe in a electrical closet or somewhere centrally located out of the way, and then just the antenna up on the roof. So what are the case studies that we have? This is a very typical installation of ours, the Scotsman Ice Systems. They're a manufacturer of ice machines. If you go to a hotel and you're on your floor and you see an ice machine, look for the name Scotsman. Good chance it's one of theirs. But they had a mixed-use office space, like many of us do. Many of our companies, where you have the corporate office area, and then you have a warehouse or the factory facility on the other half, and it's mixed use. And they were suffering with weak signal and all the problems that come along with it, right? Slow LTE, dropping calls, and what does that lead to? It really leads to lack of productivity, right? The employees are missing calls, they're having to run outside, giving their IT manager grief. So we were able to come in there with one of our certified installers and solve the problem for them with a handful of Force 5s, right? So it was able to deliver coverage for all the major carriers and gave them increase of bars and increase of signal throughout every office and every space inside of that building. So a great and happy customer with Scotsman Ice Systems. And some of the other success stories that we have, we've been installed in a lot of very well brand recognized, brand image companies that you would know, from breweries to Fortune 500 companies that you see here, as well as all 5 branches of the military. Like I said, cellular signal does not discriminate. It can be weak anywhere. Just get some metal and concrete in it, and it's going to just deteriorate the signal. But these companies have trusted SureCall for their deployments. And I encourage you to visit our website at blog.surecall.com, and you can see the case studies, and it'll kind of walk you through not only the commercial buildings and some of the other things that we've done on the public safety side, and continue to check it because we're always updating it with new case studies and testimonials of all different types of buildings and applications where SureCall was able to solve the problems of in-building weak cellular coverage. So getting started with SureCall. So we are a manufacturer, right? We like to think of ourselves as much more than just a product pusher or solution pusher. We like to support the process from beginning to end. So if you're a commercial real estate owner right now, or an IT manager, and you want to know how to get started, well, either if you do or don't have a preferred installer, get in touch with us, because we do have a nationwide network of certified installers where we teach them how to do the site survey, what to look for, measuring the outside signal strength to make sure we have enough signal to start with, understanding where cable can be run, getting the understanding of what your needs are, or where you need the improved cellular signal. So we teach them how to find out and answer all of those questions first before any commitment is made. And that's a free consultation on our part. We love to do that for you. And once we have all that information from the site survey, once the installer has completed that, we offer a free system design service as well. We take those answers from that site survey, take the floor plans, and we create a design, much like the one you see here on the bottom right-hand side of the page, a heat map through IB-Wave, and it lets you know exactly what you could expect after the system is deployed. Where you did not have coverage before, you should have coverage after the system has been commissioned. So, and then even after that, with the remote monitoring feature, with the system optimization assistance, as your installer is commissioning it, or maybe your IT manager is commissioning it, we're able to help you by remotely dialing in and making sure that everything is tuned and everything is appropriate and performing the best that it can be. So we support you from beginning to end in this entire process, and we have installation and training videos all along the way and available on our YouTube channel. So really, that's it. So just want to reiterate that we're here from the initiation to optimization, and we'd love to talk to you about your in-building needs, a no obligation conversation to see how we can help you and increase in-building signal with the passive DAS and SureCall solution. You can reach out to us on one of our social media or at sales@surecall.com. Our phone number's there, and you can reach me at fsmith@surecall.com. Thank you very much, everybody.
Okay, great. Thank you, Frankie. So we've got a bunch of questions came in while you were speaking. We're going to be talking for a while here. I'm going to leave this slide up just as a context, but we may have to jump some of the other slides to answer these. And I think we can just go through these. In fact, the first one, I'm just going to jump back to this one here. The first question is green bad on the heat map, or is green good on that bottom right there?
So on that map, I think it's inverse green is bad. It's mostly red is good, yellow, and then green. Kind of opposite what we would think, but the red nodes are where the antennas would be. So that's where you'd have the hottest signal. And then yellow, the signal degrades the further it gets away from the antenna.
Right. So while you were redialing in, I was explaining, you had a picture earlier of a office building. It's like a two-story office building with an all-glass front. And I was explaining that you may think that would have great signal from the outside coming into the building, but in reality, if you've got low-E glass, which a lot of buildings do now, then the coverage inside, or the signal inside those windows, is actually pretty poor, right?
Yep.
Looking at this building, you may think, well, surely it's got a signal from outside, but in reality, not the case.
Yeah, no, the buildings, the way they're being built today, energy efficient. So you're right, the low-E glass is the metallic, the insulation, the things that are going on top of the roof. It's built to keep everything that's inside, and everything that's outside, including cellular signal. So when you see new construction, kind of like what your graph showed earlier, the need's going to continue to rise. I think it might even scale faster than that because of the energy efficient building codes that are going up.
Right. And there's a follow-on question from this is, so in a building like this with that type of heat map, would you expect that, and I think the answer is it's going to be depends, but would you expect in those green areas that you wouldn't be able to make a call, or you maybe be able to make one, but it's going to be, wouldn't maybe be able to maintain it for a while? What sort of experience would you expect based on what you've seen?
You'd be able to make a call. Typically, what we do is when we design a system, we want to have complete coverage throughout the office or throughout the space. So you shouldn't expect any sort of degradation, especially in voice calls, right? It's if you have neg 100, neg 95, you're still going to be able to make that call. That's probably what would be in those green areas there. For example, right? Like you said, depends on the strength of signal, what's coming inside. But at the red nodes, you'd be really hot with signal. The green, you would be enough to make a phone call, right? If it wasn't, we'd put in more gear, or we'd put in more antennas, or reorient the antennas to make sure that we do get coverage in those spots. And that's where we customize it. We would customize the design exactly to tailor the needs to that building owner or building manager to make sure that we get it covered in the areas where they need coverage.
Right. And in a building without a passive DAS, of course, it's what's showing as a red hotspot here would actually be an area where there's probably no coverage at all. So those internal buildings, the break room, inner stairwell, those types of places, you're going to have nothing, I would expect.
That's right. That's right. A lot of the buildings we go into, there's usually a couple of hot spots that they have in the building where everybody runs to make a call. But yeah, for the most part, they're pretty devoid of signal.
Right. Okay. So we've got a lot of questions, got like 4 or 5 questions on pricing and things like this. So we can move on. Again, for those of you on the call, there's a lot of people on. If you do have any questions, feel free. We will be sending out the recording of this webinar in a couple of days, and also the slides will be available as well. But if you do have any questions for Frankie, now's the time to shout. So first question here, Frank, is do you charge for the site survey or the proposal process? How does that work?
So in the site survey, that's done by typically one of our certified installers or the installer of choice by the building owner, and we do not charge for that. But the installer may, right? The installer may charge a couple $100 or $300, and then once it's decided to move forward, they would apply that towards the purchase of the hardware or to the purchase of labor. So no, we don't do anything directly with the end user. We work through all the certified installers. So there's really just, it simplifies the process for everyone involved. So yeah, so we don't do that, and we don't charge for the design as well.
Okay, and what is the output from that process? I mean, do you get a schematic of your office space with like this, the green and the red, the yellow? What does it look like that they produce out of that site survey?
So after the site survey, we have a questionnaire, a building recommendation form. It's 10 questions long, and it asks things like, what's the cell signal strength outside? And we have a signal meter that the installer can go on the roof or where the outside antenna is going to be placed, and take readings in different spots for all 5 bands and notate those readings, right? Where are the strongest signals for all 5 bands? And so that's important because that's wherever the strongest area is, that's most likely where we're going to place that external antenna. We're going to ask about the building construction, because if the building is constructed out of metal and concrete throughout, we're going to need a little bit more gear, right? If it's drywall or if it's an open space, a big conference area, we may not need as much gear. So that all goes into the development process and the design process as well. And just other things like that. Are you able to run cable throughout the building, or is cable pre-ran? We try to answer all the questions or get an idea of all the questions that once we give the design out, that once they get on site with all the gear, there's no surprises. They know exactly where they're supposed to run the cable. They know exactly where the building owner has said, yes, you may put the amplifier here. Yes, you may put the antennas here. There's no aesthetics issues. There's nothing like that. We've tried to, our goal is to answer all of the objections and cover anything possible that could come up before they step on site with all the equipment to do the deployment.
Okay. All right. Sorry. Yep.
I was just saying, and also we ask for floor plans as well. To get an IB wave design like this, you got to have the design in CAD files, so we can do a heat map like this. If you don't have those, we do have a basic design process as well that also helps you understand, very similar, it just helps you understand where you can deploy and where you should put everything, all the equipment inside of the building.
Okay, good. So a couple more questions here on the deployment process, and we've got a pricing question as well. Do you offer proof of concept? So some sort of trial, so try it before you buy it type process, or do you put in a trial system in one part of the building? Is that type of thing possible?
Yeah, absolutely. Actually, a lot of our installers have units or have amplifiers on hand to where they can do these proof of concepts on their own. It's always a good thing, because then they can do that in just a couple of hours, where they can just commission it right quick. They can turn it on, and then the building personnel and the installer and everybody can see, wow, once this unit is turned on, I'm able to make a call. I'm able to have more consistent LTE data, right? So yeah, that is something that a lot of our quality installers do, that proof of concept, before they move forward in the process. So that's something that the building owner should certainly ask their certified installer about.
Okay. So while we're on certified installers here, there's a question. I'm just going to read it for you. Does the SureCall certified installer install EMT conduit if needed, or is it the customer responsible for that?
That's a good question. I know they have installed conduit before. I know we certainly run into those cases. It probably depends on that particular installer, but I know they have done it before. And a lot of our installers have very sophisticated things that they do and very sophisticated installations. I've seen many pictures of some of conduit and different types of conduit. So I don't think there'd be a problem with that or any issues with that. They would just need to verify that with their installer.
Okay. All right. It's like we opened the floodgates here. We've got more questions coming in. So, so I'm gonna this one. I think, and this was while you were dialing back in. I talked about the 75 cents per square foot on average. And the question here is, well, why is there a price for equipment if you charge by square footage? And I'm going to let you talk about the pricing schemes, how that works. But I think the 75 cents per square foot is saying that's the average cost to put the equipment in a building of a certain size, right? So you do buy the equipment in the building. Yes?
So that's an average of the equipment and the labor, right? Since we don't handle the labor, since we're the manufacturer, we don't do the labor side of it, but we see the gamut of the different types of labor charges that our certified installers and various installers charge. So 75 cents was a comfortable number. Again, I've seen some installers do a third of that, right? I've seen jobs to where it's a third of, it's 30 something cents. It's 35 cents deployed for a building. And I've seen some where it's $1 a square foot because they required plenum cable because of the building code, right? And plenum cable, for anybody that knows, is going to be very expensive to run. So we try to put that 75 cents in there as just to get an idea of what the final charge could be, but it does vary, as I just mentioned. But compared to your active DAS side, which can come in at $2 to $4+ a square foot, we're still on the far more economical side of that spectrum. So again, that's why I always encourage, our consultation is free about talking about your building and your specific needs and specific applications, so we can get an understanding and a general idea before there's any sort of commitment or even site survey for that matter.
Yep. And I know that you've installed solutions in, for example, in the basement of a building or a maintenance area or in a parking garage, right? Where you may have a multi-story underground parking garage. Maybe the top floor is covered. It's just got some signal leaking in from outside, but certainly in the lower floors, you're not going to have any outside cellular signal down there. And the cost of also putting a solution in there is going to be quite different from putting it into a Class A commercial office space, right? Yeah,
no, that's right. Actually, subterranean. You're right. So when you get underneath the ground and parking garages that are it's a lot of open space in a parking garage, but there's also a lot of concrete. But it's also a place that gets very dark, and it's very important to have cellular connectivity in case of an emergency situation. So prices can be fairly similar. Typically, it's kind of goes both ways. It's kind of a little bit easier to install in parking garages sometimes because you don't have to deal with some of the aesthetics. And cable runs can be a little bit easier and things like that. So it's certainly a great application, parking garages. And again, being a scalable solution, we've had buildings start with the parking garage in the first few floors and then come back 6 months later or put it in next year's budget to do the rest of the building. So yeah, those are great applications.
Okay, good. Okay, a couple more here. Do you have a public safety solution? And I think here they're talking specifically, that meets code requirements for the public safety organizations.
We do. We do have a public safety repeater. It's a Class B repeater. It's a great unit. It's called the Guardian. We have a new one coming out as well, but it's 700, 800 megahertz, and it's Class B and it's FirstNet ready. With public safety, it's a little bit different animal because the local authority having jurisdiction is who decides what's on the approved list and what's not. Some accept Class B boosters, some only want Class A, and Class A being very narrow, very channelized, and far more expensive. Class B, which is probably about 40% of the market, 50% of the market, is wideband, just like our boosters. So it's a little bit simpler to deploy, and it meets all the NFPA code requirements, NEMA 4 enclosure. So what's great about public safety is it's coming down the line to where it's a necessity. Buildings are going to have public safety signal, especially new buildings. If the authority who has jurisdiction, whether the fire marshal or whomever, walks into a brand new building before it's open and it doesn't have neg 95 dB worth of signal strength, that building owner will not get their certificate of occupancy. And so then it's a scramble. So everybody who's on this call, who's in new building construction in major metros, that public safety has to be a part of your plan from the ground up before it even goes into the ground, because again, that could stall your business. It could stall the opening and cost exponential dollars on the back end if you're not ready to go on the go live date.
Right. And there's a follow-on question to that is, obviously you've got, I'm going to paraphrase this, there are obviously existing emergency responder systems in those buildings. So you might have a public safety or a first responder DAS already in there. So do the different classes of systems that you have, I mean, I assume they're designed not to conflict or interfere with anything else that's out there. Yes?
That's right. They work on the public safety radio bands, which is different than what some of our cell phones operate on the voice side of things. So yeah, they're on slightly different wavelengths, slightly different frequencies, so they don't interfere.
Okay. All right. Good. Boy, we're getting through these questions here, Frankie. We're doing well. We've got a couple left, and they're actually kind of related. One of them we addressed earlier, but there's a second follow-on one as well I'm going to fold in here. So what mobile operators do you support, Verizon, AT&T, or all of them? And I know the answer to that, but I'll let you talk about that again. And can you guarantee all 4 carriers in a particular building?
So yeah, we are compatible with all carrier signals. And as far as guaranteeing what's in the building, that depends on, again, what's outside the building. If you have great AT&T or great Verizon signal, but Sprint is 0, then we cannot guarantee that Sprint signal, because we're basically taking what's outside that building, bringing it inside that building. We don't create any new signal. We take that existing signal and rebroadcast it throughout the building and then back to the carrier tower. So yeah, we're very confident in the designs. If we have the site survey completely filled out and it's accurately filled out, we certainly stand behind our product. We offer the installer 60-day money-back guarantee, so no harm, no foul. Especially if they do the proof of concept, proof of performance, really mitigating the risk as it gets further along in the process. So we have very, very few returns, very few unhappy customers. It's mostly a success story once those proper steps have been taken up front to exactly understand what the application is, what are the external variables, and how the system needs to be deployed.
Okay, great. Well, we cleared all the questions. Just for the audience, if you have any final few questions, now's the time. Otherwise, I'm going to put up the slide here. Feel free to contact Frankie and Shawcall afterward, or myself, and I can forward you on. So, Frankie, I'm going to ask you one last question, and I'm going to spring this on you because obviously you and I prepared for this, but this one's out the blue. I know you've been involved with passive DAS for some time now. When you install a system, and let's call it a large system, and you go talk to the customer afterward, what is the area that they're most pleased with? What biggest difference would you say that system makes to them? Is it coverage, or is it the quality of the signal? What is it that they comment on that? Wow, this is fantastic. I can now do X. What is the X?
It's coverage 100%, right? I mean, it is the great thing about commissioning a system when you're there, when they turn it on, and all of a sudden everybody's cell phones start dinging because they're getting alerts and notifications for the first time. And everybody's just smiling and cheers and giving you high fives. And it's a great feeling. But it's certainly coverage. They're able to finally make and receive phone calls. They're not missing calls from their customers. It is certainly hands down coverage.
Okay, good, good. All right, well, with that, we can wrap up. I want to thank you today, Frankie, for your time. This is good. I think we proved that a lot of people call that cellular is unreliable, but so can VoIP. So,
That's right.
but I want to thank you for your time today. Again, just as a wrap up here, we were recording today's webinar. We will have the recording available in a couple of days, and also we'll be sending out the slides as well. If you do have any follow-on questions, you can contact Shorcall, Frankie here. You can see the number on the screen there, or you can contact myself. You'll find my email on the invite and the original registration details. But Frankie, I want to thank you for your time today, and have a good weekend. Thank you.
Thank you, everybody. Thank you, Ian.
Thanks.